Alrighty, so now we have to implement diffing objects. So let's go ahead and start a new suite of tests by going down here and saying objects. And in objects, let's go ahead and do a basic test of throws on invalid type, which will be a function, and it'll expect make diff woe to object to throw. So this is saying we expect that if we try to have a before of a string and an after of an object, we want to throw an exception because that is obviously invalid. Now the test isn't passing yet because we haven't implemented that check. So let's go ahead and start off by doing that. So what I'm going to do is I'm going to scroll down from make diff array into make diff object. And I'm going to say if before does not equal null and not low dash is object before, throw new error. I'm going to match the same error format that I threw on the array. You can't change the type of a value. Okay, that's good. We'll save that out, and now the test is passing. Okay, so let's go ahead and write our write some basic tests. Actually, I really just want to write, because I already know this code works, so I'm not going to worry about writing a full suite of tests. I recommend that you do for all of edge cases for this kind of code, if this kind of code is your sort of thing. But let's see. Let's just do a set nested, which will have a before of whoa, hey, stuff of 1, and test of bleh. That'll be the before. The after will be whoa, hey, stuff of 2, test of bleh. And the diff should be whoa, hey, stuff of 2. So the diff should only include the value that changed. And with that, let's go ahead and implement another thing, such as add property. So for adding a property, let's start with a test of unchanged hey, and then, whoops, we want to open up an array, don't we? Unchanged of hey will be our before. Our after will be unchanged of hey, followed by an added of whoa. And then the diff will simply be an added of whoa. And let's also test removing. So remove property. The before is going to be unchanged hey to remove 1, 2, 3, followed by unchanged of hey. This should result in the toRemove property being removed. The way that we indicate if a property is removed in our diffing results is going to be like this. It's simply going to be toRemove, and it's going to be an object with remove set to true. And that's it. So now let's go ahead and make these tests work. So I'm going to say const scene for properties that we've seen. I'm going to say let object equals object, and let changed equals null. Then I'm going to say for let key in after. And I'm going to say if not after has own property key, then continue. Then I'm going to say scene at key is true. That means after has this value. That's what the scene object is tracking. Then I'm going to say const value equals after at key. And then if before is null, or not before has own property key, then we're going to say object at key equals value and changed equals true. So change just keeps track of if we've changed a value at any point. Then otherwise, if before is not null, or it doesn't have, or if it's not null and it has that property, then we have to compare the old property to the new property recursively. So I'm going to say const result equals make diff before at key value followed by location dot key. And so now I'm saying, okay, go ahead and diff the two values. And if the result does not equal is unchanged, then we know we have a new value. So object key equals result, and changed equals true. So this will recursively walk through all of those values. All of the hierarchies of both objects simultaneously until it finds a difference. Once it finds a difference, it's going to stuff it in this obj property. And that's it for the for loop. There's only one last thing to do, and that is to handle removed properties. So if before does not equal null, for let key in before, if not before has own property key or same key, then continue. So then we say changed equals true, and then object at key equals removed. This means we found a key in before that wasn't in after. And if there's a key in before that wasn't in after, well, that means we have to set it remove to true. Note the $sign. And the final thing we do at the end is say changed obj is unchanged, meaning if it changed, then go ahead and return the obj, which is our diff. Otherwise, return is unchanged. And now all my tests pass except for one. The test that's not passing is array complex update diff. So let's go take a look at that. Array complex update. And let's make sure that I got this right. It's actually working slightly better than it was before. But because I don't need to specify the IDs because I didn't reorder everything. Let's actually do two. One with an update and one with an update and reorder. So on the second one, let's reorder the item that was updated. And then we can pass in an IDs of 2 and 1. But for the update, the normal update without a reorder, we don't put in the IDs property. Remember how I checked to see if none of the orders changed, then it won't add the IDs property. And then now all my tests are passing. So yeah, I'll scroll through our diff tests real fast. So you can take a look at that. And then I will scroll through our makeDiff function. So we have makeDiff, we have makeDiffArray, which seems to be all working. I would like more tests, but this video series is not about writing diffing algorithms, or unit testing, for that matter. I just wanted to include this just to be complete as far as this series is concerned. It is kind of a fun thing to do. Especially whenever you're doing this, always write tests for this sort of thing, because it's so easy to be like, oh, I want my diffing algorithm I want to change the performance, I want to optimize it, or I want to add this new feature. If you don't have a bunch of tests like this, you might change it in such a way that breaks it in such a weird, obscure manner that you go to actually run your code in production build and suddenly you introduced a bug. So, like I said, I would prefer more tests on this, but I'm not going to spend any more time writing tests for this. Because, like I said, this is, of course, on React, not algorithms. And, I mean, this is a very crude algorithm anyway, but it works. Anyway, in the next video, we are going to write the merging algorithm. That's going to take these objects, these diff objects, apply them to the before, and return back an after. And with that, we'll see you guys then.